slide it along the wall. We see, recognizes a wooden stud.
If I turn the mic and camera on, I can say good evening to you. We'll get back to the Agile music next time. I just, a friend of mine turned me onto that one, and I just thought it was amazing how someone could play that so well on an accordion by himself. So, thanks for the indulgence. Okay, so we're going to talk today about, I've got to tell you, I think I lied to you. So we're going to split up the sixth session here into two. If we don't finish by 6:30 Central Time, we will split it, but I think we might be able to complete it before then. So what we'll do on Thursday is if there's any remainder to 6, we'll cover that. And then also Chapter 7. And we will have the review and we'll have the practice quiz on Tuesday. All right. Any questions about my lies? All right.
Nope.
So we're going to talk today about understanding problems, detecting problems, solving problems, and also managing threats and issues. So when we are presented with problems, it's usually works in two ways. What we need to do is, first of all, if we've implemented something and there's a problem in it, we've got to unwind it. We've got to undo the work that's already been done and get to be able to fix the root cause of that. So we've got to take a look at what we've done, make sure that we take out in this case, let's talk about software, the code that caused the issue. And at the same time, we have to make sure that we haven't um, you know, uh, introduced another problem with the existing code. Okay. And then what we have to do is we have to create a solution for this problem and integrate it back into what we took the bad stuff out of. And again, we need to test it, make sure that we need to verify that it didn't adversely affect anything else and that it fixed the issue that we had identified. Okay. So the longer it takes to find them, the longer it takes to fix them, and the longer it takes to get them everything back in working order, really increases the cost. And another thing to consider too is that if you can find problems earlier in your development cycle, the earliest part of your development cycle, they are so much easier and cheaper to fix than if you let things go until they're deployed and then try to fix them. Okay, because there's less rework, And that's why one of the reasons why we do iterative development too. Because if we have an issue, it's going to be contained within that, uh, you know, a Scrum time box, okay? Usually 2 weeks. So that's really what we have to investigate. All of the interfaces that we touched there, the functionality that we implemented there, rather than waiting until everything's deployed and then trying to figure out uh, exactly what all has been touched, what all needs to be fixed, and to make sure that nothing else is affected by it. Okay? So we want to catch things early. So this is just an illustration of that. Um, that the cost will actually increase exponentially, and this is using uh, waterfall type designations here, so that if we catch things in requirements, they're much easier to cheaper to fix, and the cost just keeps going up as we get into the other phases: design, coding, testing, production. Okay, and that's why, as I said, we want to be able to use agile methods. Having a fixed time box, a small time box that we're iterating over. Okay, so that all of these are done within that time box. Okay, everything from taking the user story, uh, designing, coding, solution, testing it, and uh, putting it into production. Okay. Uh, you may want to really concentrate on this, that the later in the development cycle, the more stakeholders are impacted, and therefore everything is more expensive to fix. Okay. So how can we lower the costs of change? So uh, if we're an agile team, what we do just as a normal way of doing things is to break the work that we're going to be doing into small, independent chunks. Okay, the keys here are small and independent. So what you're actually doing is you're shortening the development cycle. Okay, and we can lower the impact of the defect if these two things occur. The defects found early. Okay, that's why we talk about failing fast, so that we find the defects very early and make sure that they're addressed. Okay, and we want to be able to use technologies such as microservices architecture, which will allow us to do integration continuously. If you're not muted, please mute at this time. I'd appreciate it. And so would the rest of the people in here. Okay. So that integration, as I mentioned last time, I believe it was, especially with places like Amazon, where the integrations occurring hundreds, if not thousands of times per day. Okay. The defects are revealed early. You can fix them, get things back into production. Okay. Remember this, that shortening the feedback cycle is the key to being able to eliminate or lower the cost of defects. Okay. This feedback allows us to see what isn't working the way that we thought it would be, and gives us an opportunity to make the changes in a rapid fashion. Okay. So feedback loop, from basically the testing feedback loop, is in a traditional project in the downside of the executing phase. Is, if you remember the waterfall uh, diagrams, you have a V that's determined by all the way from requirements through deployment. Well, if you graph it like this is the V turned upside down. So if you remember your waterfall projects, that's what you see here in your traditional projects. So your feedback opportunities are during the testing, okay, because we're trying to test out the defects, trying to uncover every one that we can before the product's shipped. And so, you know, we get things that we can feed back to the developers. And I have personally been on defect calls where the defects number in the hundreds, and I classified, Sev 1, Sev 2, Sev 3, Sev 4, Sev 5, and realizing that Sev 3s and below are never going to get touched because it's too expensive, and the result from doing that, of addressing them, would be just too costly. Now, with an agile effort, you're getting feedback all along the way. Okay, uh, we're getting it in planning, we're getting it in executing, all the time, and we'll get the feedback when we whenever we deliver too. We deliver to the customer. There's also a feedback loop, so that the feedback is much earlier and it's continuous with an agile effort. Remember, we talked about the number of story points that we could stick in in an iteration. So remember, we put in 4 story points in each iteration for opportunities to learn, grow, and clean up whatever defects they found. So this is kind of a cute definition, but technical debt is the agile term for the mess left behind when you go fast. You may not be able to do everything the exact way that you want to, so that reserving some time, actually some capacity in each iteration allows you to refactor the code. So what you're going to be doing with that, you're going to be rewriting it, reorganizing it, taking advantage of different constructs if necessary. You make it more readable, and you can make it more efficient too. Okay. You can use that time or that capacity for documenting what you've been doing the documentation that's required to deploy. Moving applications, if you've got multiple environments, to move them around, do any work like that, clean up databases, just taking the time, the effort to being able to get things in, get them better organized. Okay, but realize that every iteration you need to devote some capacity for technical debt. Otherwise, it's going to pile up and pile up and pile up, and it's going to look like my desk, which is terrible right now. Okay, I've got a lot of technical debt here. Okay. Any questions on this?
So Harry, to frequently refactoring would help to keep technical debt in check also, right?
Yep. That's part of it, yes.
But one quick question before you mentioned the CI/CD and Amazon. Amazon probably, to me, it's a bad example. They deploy, meaning that in a good way, bad example, because they deploy to their production, they touch their production boxes every 11 seconds.
Yep.
That's why I'm saying like this is extreme. We don't even need to touch our production boxes that often, right? My question was like, when in our environment, when we don't have a robust CI/CD, so to speak, and everywhere just yet, how do you think we can catch defects early enough without having a CI/CD that really in existence, so to speak?
defects can be removed or identified many different ways. One method that I've used before is a structured way of reading through the resulting code or resulting, work product by an independent party, just taking a look at it and interpreting it, paraphrasing it and feeding it back with the author there, okay, to make sure that we have agreement on what was produced. Okay, uh, doing the same thing with the tests that have been created. Ideally, they're going to be in a Gherkin format to be able to eventually automate them, and being sure that we have uh, an agreeable amount of code coverage with the tests and profiling the code. And other than that, really, it's the attempts at integration or the integration of the code into the main line is really the way to test it. It's really the way to verify that we don't have the defects there.
Yeah, well, that makes sense.
Yeah, there. I mean, continuous integration, continuous deployment. That is the ideal way of doing it. And then we have to cobble something up if we don't have that capability.
Sure.
Keep making noise that we need that capability.
Exactly.
Which does require
Yeah.
everybody involved with it, from architecture to product owners to everybody involved with it, to have the atomic pieces that can be, excuse me, implemented readily, integrated readily, tested readily. So it doesn't work if you've got big globs here rather than small pieces. And they work hand in hand. So we've got to tailor our features, our stories, to be as small as possible in order for things to work right.
Sure, makes sense. Thank you.
Okay, sure. Okay. What we need to do is create a safe and open environment. We talked about psychological safety before, where people feel that they can have failures, that failures will lead to better results for the overall product. Okay, so that people have a comfort level, a high comfort level of trying new and different things, of being able to experiment with ways of doing things, with ways of producing value. And we can talk about our failures without being called out on them, without being having any adverse reaction to failing. Okay. If we're able to talk about things, if we're able to, uh, help each other put things together, if someone's having a problem, a safe and open environment allows people to offer their help. If something's is critical to get done, then you can swarm on it. Okay. So also remember the note here that the exam's going to refer to safe and open environments. It's also critical to any agile transformation or agile team. Without a safe and open environment, without this component, the rest is just process and fails to deliver results. We've seen this before last week. Yeah, would have been last week. A different way of expressing it. The thing is that the psychological safety is the most important component of having a high performing agile team and being able to go through an agile transformation, because people are not going to perform optimally the first time. If we're able to create that psychological safety, they're willing to try different things, they're willing to fail, and the results end up better. Okay. Any questions on that section? Any more? Okay. Let's move on to detecting problems. Okay. Now, know the definition of lead time. So lead time is the time it takes for work to go through the entire process, end to end, from initiation through closing. Okay. So in a traditional process, the lead time goes all the way from initiating through closing. Okay. With, say, a Kanban, your lead time is when it enters the Kanban to the point where it's accepted. So that if we have small pieces moving through here very rapidly, the lead time is decreased using an agile method as opposed to using traditional methods. Okay, where your lead time is from the time you start until you basically receive the revenue. So we break up the deliveries using agile methods, and by doing that, we decrease the lead time also. Okay. So you can, on say a Kanban, determine the cycle time between any two any two lanes or columns on a Kanban board. Okay. So know that you can have cycle time that's defined as being for development and test. What's your development test cycle? Okay. You can also have determine the cycle time for development alone if you're keeping the right metrics. You can have a cycle time that goes from the production of stories until deployment, if that makes sense in your process. Okay, so cycle time is just the amount of time that work spends in a particular lane or number of lanes. Okay. We took a look at how it's easier to move through the entire process if you have a batch of 1 rather than a batch of 10. Okay. And the lead time, the cycle time can be measured through, as I said, any of the one or combination of parts of our overall process. Now, they need to be adjacent if you're measuring them. Okay, it doesn't make sense to combine, like in this here, the definition column and the deploy column without including development and test. Okay, you can look at these individually, but if they're not adjacent, or that your cycle time is not considering everything in between, then that's not a measure of cycle time. Okay, it's got to be like this. It's got to be next to each other, or it has to include everything and everything in between. Okay, any question on that? You may get a question on the exam about that. Okay. WIP limits. Have we talked about WIP limits before?
Yes.
Okay. So you can have a WIP limit on any one of the columns. Okay. So you want to be able to optimize what your WIP limits are. It's going to be determined by the number of people you have working on a particular lane, how quickly they can clear things, how quickly everything downstream from them can be cleared. Okay, it's what we can do by by limiting the amount of work in progress, we can eliminate bottlenecks. So if we see a bottleneck in our process, if something just keeps getting stacked up in test, one of the ways to eliminate that bottleneck is to limit the number of cards that we can have in the test column. Okay. So what these WIP limits are doing is throttling down the amount of cards that we can have throughout the entire process so that people can concentrate on them and move them to the right quicker. Okay. Throughput or velocity is the amount of work the team can get done in one iteration. Okay, now you need to know both terms, throughput and velocity. Okay, so as it says here, velocity is one way to measure throughput. You can measure throughput as cycle time and the amount of work in progress. And we'll go over that in a second here. So just realize that throughput is some measurement of work divided by an amount of time. Okay, so in this case, if we're talking velocity, 20 points in 10 days is the throughput for that. So 2 points a day. You're not going to have to calculate this on the test. You may have to do some comparisons or determine which is more effective, a throughput of 2 points per day or a throughput of 20 points per day. Obvious questions like that. So these are just different ways that you can go about expressing these things. Just to remember, we talked about Little's law. The cycle time or the amount of time that it takes for work to progress to the front of the queue is equal to the number of items in the queue divided by the processing rate. Okay. So think about it like this. When the highway has fewer cars, spend less time on the road. That's the throughput. You want to maximize the throughput through your process. Okay. Know how this equation is set up. The cycle time is equal to work in progress divided by throughput. So in this example, you're not going to have to do the calculation itself. Know what the relationships are, though. The cycle time is equal to WIP divided by throughput. Okay. So, in other words, the amount of time that is spent within this column or number of columns on that Kanban is equal to the amount of work in progress divided by how quickly you can process this work, or the throughput. Okay. So if you're able to do 2 points per day, you've got 5 points in progress. Your cycle time is 5 divided by 2, or 2.5 days. Okay. Just different ways of looking at these variables. Okay, you had this one, calculating throughput. Okay, if you've got cycle time and you've got WIP, you can calculate throughput. If you have, the same thing. Okay, you just need to know the relationships here. Realize that productivity increases if throughput increases. Alternatively, if cycle time decreases, productivity also increases. So you've got two factors on productivity. If you increase your throughput, if you can handle more things per unit of time, that increases productivity. You're able to do more. If your cycle time decreases, that's basically the same measurement. You're able to produce something, or your productivity increases because you take less time to do it. Okay. Now, the key factors for being able to do this is a stable team, so that you're not adding people or taking people away. We don't, the historic way of building up a team then breaking it back down doesn't apply here. We want the agile teams to be feature dedicated or product dedicated, stable, and together for a substantial amount of time, so that they can learn from each other, that they can learn how people do things, and they can come up with their own ways of being more productive the longer that they work together. Okay. If we can measure cycle time, if we can measure throughput, we can help to optimize the entire development process. One of the things is breaking work down into much smaller, manageable chunks. Remember we talked about invest last time? No. Okay. Following the invest process. Keeping the team 100% dedicated and 100% stable. Now, when we talk about 100% dedicated, we're not talking 8 or 10 hours a day per person where they're just producing that product. Okay. In software development, we also have a lot of meetings. We have overhead. So, the dedication means that they're staying on that particular effort. They're not dividing time between 2 or 3 different efforts. Okay. And that you retain the team members. Also, we don't mess around with the backlog. Okay. Once the iteration is set, ideally you don't change what the priority order is the team needs to work on. Okay. You change that, it's going to have adverse effects. Unless you do it on a boundary where whoever is going to be addressing that problem or addressing that effort, okay, unless they're 100% dedicated, if they don't have to stop other work, then yeah, you can do something like that. But if you're pulling people off of work that they've started, they've got a context switch. They lose effectiveness by doing this. Okay, so we really want to keep introducing different things into an iteration to the iteration boundaries, so we can prioritize that new request in with the others in the backlog. Okay. And we can improve the time that it takes to resolve defects by the Scrum Master. Definitely, those are some of the impediments that the Scrum Master can work on eliminating. We need to make sure that the teams working on this effort have the proper tools so where they can do the analysis and have the tools to be able to do the root cause determination. Okay. We need to improve how the defects are addressed and retested. Okay. And work to find the defects sooner whether it's by CI/CD methods or other methods that we come up with that allow us to do that. I mean, that's part of the whole effort. Being able to experiment with these things, be able to improve the way we do things. Okay. Trend analysis is another way to take a look at past performance and try to project when we're going to finish or how much capacity we're going to have. Okay. One of the best ways of doing that is with charting it so that you have a visual representation of your trends. In this case, we're taking a look at open defects over time. And usually the defects peak after a deployment and then are brought back down until the next deployment where they peak again. And this goes on and on and on throughout the testing of the product. Okay, so what we want to be able to do is plot what the trend is on these. This isn't, point for point, but you can use things like either the mean or the median for the number of defects at any time, and just be able to connect the dots then and show what is happening here. And we can see graphically that the open defects, although they keep spiking, those spikes are getting smaller and smaller and smaller, or lower and lower and lower. Okay, that's what we want to be able to portray on a graph like this or a chart like this. Okay. There may be a question or two on control limits. I mean, the control limit is an acceptable deviation from the standard at any point in time. So as you can see here, there have been two limits determined, an upper limit and a lower limit. And for most of the time, okay, the trend has been to be able to do more and more story points here. In iteration 2, though, there was a dramatic dip that was outside of the lower limit. That's where we can get valuable information, and just by tracking your velocity. And how do you establish the upper and lower limits, your control lines? Well, it depends on what you're producing. Okay. It has to be high enough quality to be able to ship to the customer and be useful to them. Okay. If it's a mechanical part that you're producing, there's usually some tolerances that are specified by the customer, or we're building to a certain tolerance. And that's what these represent. If it's plus or minus 10,000ths of an inch on machined parts, then that's what our upper and lower limits are. A thousandth of an inch up, a thousandth of an inch below. Okay, if a part comes off the line and it is outside of that control limit, then it needs to be rejected because it doesn't meet specification. And that's why you see so many times, if you're dealing with any mechanical parts, you'll see a tolerance on it of plus or minus a certain number of thousandths of an inch. Okay. The acceptable limits on those will be what your controls are here. Any questions on that?
So Harry, this is story points for multiple iterations, right? And the beginning of the iteration, beginning of the project, maybe we have some of the easier stories, epics we like to get out of, because that's why we would like to deliver something fast
Yep.
to earn the trust. As we move on to future iteration things, the level of complexity of the work can increase, and other factors come in, the security, and then other unknown issues are popping up. So team might produce less number of user story.
Mhm.
So my point is the nature of work, the complexity of the work in iteration 1 compared to 7 and 8 could be very different.
Yep.
So if they produce less user story, should they be penalized, saying like you're not as productive? And how do we
Well, that's an
make sure?
opportunity to investigate. Is it something that is systemic? Is it caused by the complexity of the work having increased dramatically? Now, these ah, these graphs, these charts are opportunities to enter into a dialogue and do root cause analysis. All this stuff we're talking about are communication vehicles, so that you don't just sit back and wait for something to fail. You're taking measurements along the way. You're looking at trends. You're looking at whether or not things are within your control limits. And if they're not, then you need to do some investigation. If they are, then you're going to assume that things are okay, that you're able to ship product based on that. Okay. So if you dip down below your lower control limit, say in iteration 7 or 8 or program increment 7 or 8, when you're really getting into a complex system, then yeah, it's something that needs to be discussed. Is it a failure? Is it something that's going to adversely impact the ability to ship the product or for the customer to use the product? Or is it something, as you pointed out, Mohammed, that it was caused by an increase in complexity? So yeah, it can be positive, it can be negative, it can be just a vehicle too.
Right. Okay. Thanks. Just what are the ideas? Just we try to gain some kind of insight to understand what has happened, and then describe, and more importantly, prepare for the future, taking this into considerations. Okay. Thank
Yep,
you.
sure. And that's the thing. In general, what we're doing is we're taking a look at things all along the way. Anytime we hit a time box, we've got a formal review. We've got a retrospective. If we find out, hey, we've only done 15 story points this iteration, you know, let's dig into that because we usually do 21. And you may find out that uh, Harry took vacation for 3 days, and nobody else cleaned up the garbage can or something like that, or that, as you said, the complexity of the work that came in was, or that the work was something that was totally different that people um, didn't have the background for. So identifying that root cause is important, because we want to be able to fairly accurately predict how much work a team can accomplish in any time box that we have.
Right. Gotcha. Thanks.
Sure. All right. Any other questions on those? All right. Let's talk about managing threats. Okay. Um, what you can do, you're most likely not going to have to calculate earned monetary value. Okay. But the way you do it, though, is you're really assigning a dollar impact to a risk if it happens, and taking into account the probability of whether or not it's going to happen. Okay. So that EMV is simply the risk impact in dollars. How much are you going to lose? What kind of market opportunity are you going to lose if that risk occurs? And then the probability that it's going to occur, from 0 to 100%. Okay. And what you want to be able to do then is to mitigate those risks one way or another. Okay. You may be able to do things proactively so that the remediation for these risks then enters the backlog and is prioritized. If it's a low risk item, if the impact isn't much, you may not have to do anything. You may be willing and able to accept that risk and deal with it if it occurs. If, for example, you've got a huge amount of cash that you're either not going to realize or that you're going to have to pay out if that risk occurs, and it's very probable that it's going to happen, like if you're an insurance company, okay, and you insure homes and businesses in the state of Florida, you have to do your risk analysis for hurricane season especially. So every year there's going to be some sort of hurricane activity. So your earned monetary value is going to be what your risk impact is. And if you see things like what happened with Ian, there is well over $1 billion worth of damage that was done. And so you have to be able to plan for that. And also you have to assess the risk probability, the probability that that risk is going to occur. So between the two, that's what you have to plan for. Okay. Now, the risk severity is the risk probability times the risk impact. So this is dimensionless. It's takes away the dollar amounts. Okay, we're doing this on a 3-point scale on the for each the impact, the probability, and then determining what the severity is by multiplying the two columns. Okay, so if you have an impact of 2, a probability of 3 that it's going to occur, that means that it's a medium impact. The probability is high that it's going to occur, so your severity is going to be 6. Your maximum severity in this, using this method, is going to be 9. Okay, so you have a 3-point scale: 1 low, 2 medium, 3 high. And say for a second risk, if your impact's low, your probability is high, your severity is going to be in the middle. Okay. Reverse them, and the same thing's true. If you've got a 1 and a 1, 1 times 1's 1. So that would be a low severity. So you can go from 1 to 9 in discrete steps. Okay, so 1 times 1, 1 times 2, 1 times 3, 2 times 1, 2 times 2, 2 times 3, and 3 times 1, 3 times 2, and 3 times 3 as the severities that can occur. Okay, so highest, again, is 9. The lowest is 1. Okay. A risk progress chart is really just month over month how the risks have progressed, what you've done to mitigate them. So you're really looking at the severity. Now, these numbers can change. The impact that can change. Probability will definitely change as you mitigate the risks over time. So what we can see here is that the impact on risk 1 is 2, the impact on risk 2 is 1, and the impact from risk 3 is 3. So medium impact, low impact, high impact. Probabilities, well, they're all over the board too. So it's a high probability that this 2 impact risk will occur. Okay, so your severity for this one's 6, the other 2 are 3 apiece. That's in January. The end of February, what do we have? When we take a look at things, well, that risk 1 has been mitigated somewhat so that the probability is now down to low. Okay, so instead of the probability being 6, it's now 2. Okay. The same thing with risk 2. It has been able to mitigate it somewhat so that the severity is now 1. Okay. This can occur also with, you know, oh, it left me right now. But anyway, risk 3, same thing. You start out with a severity of 3. If you're able to fully mitigate the risk, it goes down to a 0. And I know we didn't say 0 was allowed, but you can go down to 0 if you've totally mitigated the probability that will never occur. Okay. So what you really want to do is end up in with zeros at uh, at the earliest period of time that you can. Okay, and in March, all of the risks have been addressed for this particular effort. So risk 1, risk 2, and risk 3, we're saying that the probability is 0 that they will occur. So just by definition, that means that the severity is down to 0 for each one. Okay. Remember we talked about burn down charts before, where we take a look at the number of, say, story points that are produced and delivered in as a function of time. Well, this is the same thing with risk. This graph just plots the table that we saw in the last on the last page, so that the total risk, the total severity is additive here. So you start at 12, you jump down to 2, and then you're totally mitigated by the time you hit the end of March. Okay. And then each of these 3 is one of the risks. Okay. So the lightest color of the 3 is risk 1, then risk 2, and risk 3. Okay, so this states in one chart or one graph the burn down of the overall risks, the overall severity of risks, along with each individual one. So this is a pretty common way of taking a look at it. Okay. Now, concept here is that a risk will cost to mitigate, and that it will return a certain value in effort avoided, waste avoided, all those things. Okay. The what we're doing here is inserting the mitigations to these risks into the backlog. Okay. And the way we calculated the impact probability times probability, so that 50% of 5,000 is 2,500, 10% of 1,500 being 150. So the estimated value is 2,500 for the first risk, 150 for the second. We fit those mitigations into the backlog in the appropriate position so that we have a progression from highest impact down to lowest impact. Okay, all the way from feature A down through risk 2. See how we can do that? Can anybody see how we can do that? What if I had a risk that had an impact of $10,000 and a probability of 63%? Where would that go in here?
And a probability of what? I'm sorry. 63%.
63%. Yeah, just for grins. So your impact's going to be what? $6,300, right?
So, in this, and where would it go in this particular?
Yep.
Backlog?
Yep.
Then I guess I would put it right around above risk 1.
Yep. That's how you do it. Now you're probably not going to have to do a calculation of 63% of $1,437.26 or anything like that. They will ask where a risk that has an EMV of $2,500 or $6,300 would fit in here. And they'll give you choices between A and B, between B and risk 1, between risk 1 and feature C, or between feature C and risk 2. That's the type of question that you're going to get. Okay. All right. We've got problems. We've identified them. How about if we solve some? Okay. What we want to be able to do is have continuous improvement of everything that we do, so that we want to be able to prevent problems coming up. Actually, we don't want to have to deal with them as a way of doing business. And we want to put things in place to eliminate problems in our processes. Okay. So that in order to do that, the most effective way is to engage the entire team, so that you have multiple people offering the solutions, evaluating the solutions, okay, identifying what the problem is, and really scoping it out. Give me 1 second here. I got an underappreciated dog. We've only been holding each other for 23 hours today. All right. So that one concept that you need to remember is that leaders don't take problems away from the team and solve them on their own. That is not what a leader does. A leader enables the team to solve their own problems. Okay. Yep, we finished early today. So, questions?
Oh, wow.
Yeah. That's why I said I lied to you. Chapter 6 is not that long. I just seem to remember the last
that was a
time.
whopper.
Yeah, well.
And in the book, it says that only 10% of the questions of the test comes from that chapter.
Yep.
I thought it was not that many questions.
Say again, please, Alma.
I thought that was not that many questions from just one chapter.
No, you're going to have with what 120 questions. That at the most you're going to have a dozen.
But you will have enough time to get to your doctor's appointment.
Yeah, well, I'll find a way to procrastinate. I'll be late. Don't worry.
Okay.
So,
Your dog is good.
yeah.
This doesn't really address it very much the way previous and I kind of think I probably know the answer, but in your experience with Agile, what is the biggest obstacle to problem solving? Is it the trust issues or
Psychological safety.
okay? That's what I was thinking, but
Yeah, the just the opportunity to have the time to really do good root cause analysis and determine what the problems are, come up with a really good workable solution. Okay, first one may not work, okay? So that that safety has to be there in order for people to feel that they can try different things. And leadership has to understand that. They have to sponsor it. They have to be really active and proactive in making sure that people realize that they're going to you know, need to take that time and that they can fail. And I mean, Mohammed and I are working together in, you know, during regular workday on transformation for the team that he's responsible for in, it's the whole HR analytics team. And one really um, profound thing that his AVP has done is talk to his entire team about that concept, about psychological safety, about the realization that you may not get the right answer the first time, so that it's okay to fail and that the entire team can learn from it. That's the type of sponsorship you have to have. That's the type of an environment that has to be established to encourage problem solving, to encourage experimentation, and come up with a much better product. I hope you didn't mind me revealing our relationship, Mohammed.
No, that's good. I think it is having that support from the leadership is crucial.
Yep. Yep. That's what we try to coach in every organization. And it's just very fortunate that the HR analytics team that is there, that support's there, that sponsorship's there. And the results are going to start screaming in, really.
Yeah, that's for sure. And then also not to diminish the foot soldiers role, right? Yeah, leadership support is there, but like you mentioned before, the agile is the mindset. To build that mindset, the people of the organization, that takes a lot of time, a lot of repetitions, and um, that's a hard job. Yeah,
Yep.
with time it'll come.
Yeah. Um, you know, one of the things that we're doing with Mohammed's team is making sure that everyone has a good foundation in Agile. So the Agile COE, and it's really some consultants who have been working with us, have come up with some Agile Basics courses. Very short ones, they're only 90 minutes apiece, but Agile Basics 1, 2, and 3. And we've been through the first two so far. We've been doing them a week apart, and the results are already starting to show, with people being able to use the same terminology, to be able to identify things, you know, in their process, taking a look at how things are done. So it does take time, and at the same time, you can you can have an impact. Okay, and it's the same thing as delivering a product using an agile mindset and tools that support that. We do it iteratively. Okay? We keep building on things. And that's where you get the ability to transform an entire organization. With good sponsorship, people taking the time to really work on changing their mindset and building upon the concepts and learning more and more and more about it. Okay. Any other questions or comments? Okay. All right. I guess we'll just adjourn early today and you can get back to stealing the kids' Halloween candy.
Thank you.
Okay. Have a good night.
Sounds good.
You too.
Have a
Thanks.
good one.
You too.
Bye-bye.
Bye.
Bye, everyone.
Bye-bye.